Today's subject, I'm going to go way back to the beginnings, and I'm going to talk about what I think possibly you should be doing if you're looking to get into software development today. Well, here we are. Welcome to Narcolepsy Pumpkin. I'm Andy. If you haven't done already, why not click on subscribe and click on the bell. That way you'll get notifications when I post new videos. So welcome to another rant on the road. There's quite a lot of boot camps and things like that for Python and other quite high level languages. Now, I would honestly suggest it is worth getting a good understanding of how hardware and that hardware is architected, because that'll give you some insight into some of the problems you're going to encounter in the real world. Because a lot of modern languages basically provide a virtual environment, such as Java and C#, where we're running on top of a kind of infinite amount of memory and an infinite amount of stack space, the assumption is that the language or the underlying platform framework is going to do all the tidying up for you. If you learn one of these languages as your first one, yes, it's going to give you some understanding of sequence, branching, and recursion, which is the three key parts of all software development languages, but it isn't necessarily going to give you an understanding of what's going on under the hood. And that understanding of what's going on under the hood helps if you end up working in embedded systems or in something where there's a little bit more of a constraint on memory. Even writing software natively for things like the Raspberry Pi Pico and the Raspberry Pi, not necessarily in a high level language, but on the native hardware itself, potentially gives you a better understanding of how a lot of things that some low level software is going to be doing. Also, understanding how things are actually stored, so the difference between pointers and structures, and where those things actually get put, because that starts to get quite complicated in high level languages. Some of the things you think might be on the heap are actually on the stack, and vice versa. And the way you write code can have an influence on where things are stored and how quickly you run out of particular types of memory. If you want to know a little bit more about this, or refresh some of your understanding, I would honestly suggest doing it in a kind of 8-bit world. So look at some of the older CPUs and machines that were around in the 80s, because it's far easier to understand the fundamental concepts of this working in 8 bits than it is trying to go in full 64 on a modern processor. For example, if you wanted to do assembler using 6502, where it's only got 2 registers and an accumulator, is much easier than trying to do it on a modern processor where there's up to 64 registers that are doing all sorts of crazy things. So there's my rant for today, with a bit of advice on maybe looking a bit closer at the hardware you're actually running your software on, because that might mould how you approach it in the future. Hope you've enjoyed this video, and please click like, click subscribe, and click on the bell. Thanks for watching.